Welcome to today's deep dive. Usually when you are, looking at a display cable, you expect it to be a cheap afterthought.
Right, like maybe 20 bucks at most usually.
Exactly. But our mission today is to decode a piece of technology that looks incredibly simple on the outside, yet it costs a staggering $1,090. We are talking about the DVIGear DVI-28100-AOC DisplayPort cable.
It is honestly just a phenomenal piece of engineering. When you look closely at what it's actually doing, you realize this isn't just a cord for hooking up a gaming monitor.
Right.
It is a structural solution for extreme environments.
Okay, let's unpack this because the specs we are looking at are frankly insane. Like this cable stretches up to 100 meters.
Which is about 328 feet.
Yeah, and it is managing a total bandwidth of 32.4 gigabits per second, pushing, 8K video at 30 hertz or 4K at 120 hertz. I mean, how is that physically possible?
Well, it fundamentally bypasses the physical limitations of traditional copper. With standard copper wire, high-frequency signals suffer from severe attenuation and interference over distance.
Right.
The electrical resistance basically turns that pristine data stream into heat and noise before it even reaches, 50 feet.
So trying to push that much electrical data through copper over a football field is basically, it's like trying to accurately shoot a high-pressure fire hose of data perfectly across an entire stadium.
That is a great analogy.
By the time it reaches the other side, it is just a mess.
Exactly, which is why what's fascinating here is that it isn't a traditional cable. It is an active optical cable, a hybrid.
Oh, okay, a hybrid.
Yeah, it contains 6 standard copper wires to handle the basic device handshaking. But the heavy lifting of the massive video data is handled by 4 strands of glass optical fiber.
Wait, glass?
Yes. The connector itself houses a tiny optical engine utilizing 850 nanometer lasers to instantly translate the electrical signal into light.
Wait, hold on. I'm looking at this and you're telling me there are literal lasers firing inside this cord to move the data.
Yep, actual lasers.
But lasers require power. Are installers having to, run a separate power line or plug in some massive power brick just to keep the cable itself turned on?
You would think so, but that is the genius of the optical engine design. Because it uses light, rather than forcing an electrical current against high resistance, it runs on an ultra-low amount of power.
Really? How low are we talking?
We're talking about an operating draw of under 0.43 watts.
Oh, wow. That is nothing.
Right. It pulls this tiny trickle of power directly from the DisplayPort source device itself. It completely eliminates the need for any bulky external power adapters.
Okay, here's where it gets really interesting. Logistically, if we've solved the distance and power problems, we still have a physical reality to deal with.
The installation part.
Right. If I'm an installer trying to snake 300 feet of delicate glass through a tiny wall conduit, a massive, rigid DisplayPort connector isn't going to fit through those pipes.
Right. And DVIGear engineered a workaround for that exact friction point. One end of the cable features a detachable mini DisplayPort connector with a locking pin.
Oh, that is smart.
Yeah. So installers can easily thread this ultra-compact, low-profile end through tight conduits.
And then they just attach the full-size end later?
Exactly. Once it is safely pulled through, they simply snap on the full-size adapter.
That perfectly solves the mechanical side. But let's talk about the environment. Because I noticed this cable is also plenum rated.
Yes.
I see that term thrown around in commercial AV gear, but why does the plastic jacket on a cable justify such a massive price tag?
Well, if we connect this to the bigger picture, it comes down to commercial life safety. A standard PVC cable jacket will release highly toxic, thick black smoke if it catches fire.
Yikes.
And in massive commercial buildings, cables are heavily routed through the plenum spaces, those drop ceilings, and raised floors that also circulate the HVAC air.
Oh, so a fire would spread those fumes everywhere.
Exactly. It would essentially gas out the entire building through the vents. A plenum-rated jacket is engineered from specialized fire-resistant materials to prevent that entirely.
Got it. And it also has a uniquely low RFI and EMI profile, meaning it doesn't leak or absorb any radio frequency or electromagnetic interference, right?
Spot on. The optical fibers are entirely immune to electrical noise. This isn't for a living room. It is engineered for interference-free professional environments.
Like hospitals, right?
Yes, think about a hospital running highly sensitive MRI imaging equipment or a massive military AV control room. A single dropped frame or spark of interference in those environments is unacceptable.
So what does this all mean? It means the traditional bottlenecks of high-end AV, the physical limits of traditional copper wire are effectively gone.
They really are.
We are moving massive amounts of data further, faster, and more flawlessly than ever before.
Absolutely. And I think the big takeaway for you listening is the next time you see a flawless, massive 8K display in a public space, consider the invisible, highly engineered glass infrastructure hiding inside the walls, making that digital magic possible.